Hello everyone, this is Scott with US Ignite, and this is episode 2 in my ongoing series of Docker tutorials. Last time I covered Docker conceptually, from a conceptual point of view, sort of what's going on, what does it do, what are the components constructed of. Today I want to talk a little bit about working with images and containers, and I'm going to do a lot of command line stuff today. So we're really getting into the nitty gritty of actually running Docker. First, like a lot of things though, there's a couple theories I want to make sure I get across in today's demo. So I want to show you this little diagram. The kind of conceptually important thing to understand is, as I said in last episode, what you have are a Docker image and you have Docker containers. And Docker images are virtual images sitting on file system at rest that you will spawn to create containers that actually run applications. And those images might be combined with files you're bringing from the file system, or you might give it some instructions to install some files for the actual container. But the root of what is going to be launched and what is kept pristine is what's coming from the image. Those images that are local to your operating system are pulled down from either a private registry or from Docker Hub somewhere. And so you'll always start with some base image of some kind, and that might be just an Ubuntu image that comes from the official Docker Hub registry that you build up over time and commit to yourself, either back to Docker Hub or to your private registry, or it'll be some image that a partner has created or some community member has created that you're using. But the idea is still central, that you'll be pulling a base image from somewhere, combining that with some instructions to launch on your local system, or combining it with instructions to launch and then save as a version of an image for yourself, and then perhaps pushing it back to your own registry. So from the registry level, you're going to do two central types of operations: pull, which means you'll pull an image from that to your local system, or build, which means you'll combine an image you're pulling from one of the registries with some instructions to build it on your local system. So how fast Docker can run a container usually depends on how many resources are put down locally on your local image. So you'll see a few examples of both, but one of the real strengths of Docker is if you have an image built on your local system and ready to go, once you launch it to run a container, it runs extremely quickly, and that's one of the advantages of Docker. All right, so on your local system side, you have that image which is built on your local system either by pulling it first or building it, or it might automatically build it as part of a run command. Once it's on your local system, that interacts with containers. As I mentioned in our last episode, the way to think about it is that you think about images as sort of class definitions in programming, and containers are spawned objects from that class. So in this case, containers are run from an image that's brought up into memory, and then it's detached from that base image, and it has its own life until you remove it. You can add things to it. You can change that container. You can modify that container. You can serve out to the world from it, all those sorts of things. You can even create a new image from that container with a commit, and there's some other routes about Docker files that we'll get into a later episode. But you can create new images from containers that you built up and modify over time. And in this way, you can have versions of images that you add over time and create different versions of applications that you might deploy or environments that you might run. And it's extremely useful because, especially when you have the images built on your system, all these different versions can be tagged and they can be shut down and run in very quick succession. So it's a great way to run DevOps or swap out services on the back end without too much interruption for the user. All right, so let's go to command line examples here and just get into the nitty-gritty of Docker itself. So I'm going to close this out. So Docker, right here, I'm going to run a web service, and you can see there's nothing running at this location. If I hit return again, it just shows me no connection. But let's go over to the command line. What I'm showing you here is Docker for Windows, is Docker Toolbox. This interface might change for you. There's a few extra complications that come in when you use it. Docker Toolbox on Windows or Mac, and I'm using it because this expresses those complications in a way that I hope is meaningful for everyone. But note that this is going away in really a matter of months, we think. Docker has a beta version right now that works natively with Windows, natively with Mac OS, so you won't have to deal with this when you get into Docker. However, understand that often a lot of the tutorial material, a lot of the tutorial documentation has been built around this current paradigm of Docker Toolbox. So you might see it for the next year or two until that material expires, really. Don't get too confused by it. I just want you to know it exists. So that's what we're going to do here. Okay, first, let's get into Docker and see what we have on our system. And there's two base commands that you want to be able to use. The first is docker images. And doing that will list images that you have, Docker images that you have built up on your system already. You can see I have one image that's pulled down already called nginx. That's the official nginx distribution. We'll get to that in a second. But that's on my local system. Its size is 182 megabytes. And it was created, last updated 5 days ago at least, because I'm using the latest version. So that's images, the images I have sit on my system. You'll see when we start going through running and building these Docker images later that I get more images on my system, but right now that's the only image I have. And the other is Docker run. Docker run actually runs an image and spawns it as a container onto your system so that it's available for you to use. And the anatomy of a Docker run command is docker help run. Is pretty straightforward. As you can see, there's a ton of options that you can pass a command line. A lot of people set these up as bash aliases so they can easily do them. And we'll get into something called dockerfiles later, which help you quite a bit to cut down on the complexity here. But the base anatomy of a Docker run is Docker run, whatever options you want to give it, the name of the image that you want to run, the command that you want to run in that image, and whatever arguments you're passing to that command. That's basically it. Most of the common options you see are about demonizing whatever process you're running in the container, about opening and closing ports, and maybe naming the container. Because if you don't name a container, it's assigned a random name when it comes up, and sometimes you forget what container does what. So it's often best practice to go ahead and name your containers when you run them. So Docker run, options, the image name, and the command that you're going to run. So let's actually do an example of this. Quick bash hello world. And we'll get going. So down here, let's do docker run Ubuntu bin echo hello world. So we avoid the curse of the gods. Okay, what that's doing is it's using the docker run command. On it, I'm not giving it any options, but it is running off an image called Ubuntu. It's using the command bin echo and the argument hello world. So it's just the same as doing a hello world echo. And I'll do that. It says it's unable to find it locally, which means it first looks on your local system if you have an image already built. When it doesn't find it, it goes out to Docker Hub by default, and that's what you're seeing happen right now. There are layers of images. Those are versions of it that have been downloaded over time. And you can see down, it echoed out hello world here in my lower window, and it says it has a newer image. So let's go ahead and Docker images. And you can see now I have Ubuntu. This thing called tag means that that's a way of versioning images over time. They can be given tags to differentiate versions of an image. That maps to Git very well, or conceptually. And you notice there's a lot of there's a lot of strong similarities between this and Git. So that lets you version images over time. And by default, it pulls the latest tag. I could have given it a version tag, and tags are based up to the person committing it. So they can be anything, but by default, I know the Ubuntu image on Docker uses Ubuntu version. So we'll get to one shortly where I do a 1404 image tag and pull down that version. Another thing to point out here is image repository names. Normally, when you're dealing with community Docker images, you'll see a username / the name of the image that they're using. Very similar to GitHub and how you see GitHub commits. When you see something without a user and a / and it's just a root, like Ubuntu or nginx, that means it's an official image where Docker has collaborated with the developers or the devs over at that project, and they're building official good images that are available from Docker Hub. So if you pull from those images, you usually know that they're secure, nobody has mess with the internals of it, and you're not getting any kind of weird corruption from that image. When you're pulling down from Docker Hub, you do generally want to worry about what has been put on that image. If you're deploying an application, you only want to pull down from trusted users, and certainly if you can get from a trusted repository, that's a great way to go, and that's something to keep in mind. Okay, so we've done our hello world. We have avoided the anger of the gods by not doing hello world. Let's go to something a little bit more meaningful. So let's talk about the difference between containers and images themselves. So let's go ahead, and another command is docker ps. That lets you know what processes are running. Right now you see no processes, no Docker container are running as live, they're as running as processes. But if I do docker PSA, because docker ps only returns running containers. So that's something to be aware of. If you look at PSA, though, that gives you all containers. Containers can either be launched or stopped, and they're still containers, and those containers can be relaunched. So you can see that this container is the container I just ran. It says it's from the Ubuntu image, and the command that it was given was bin echo hello world, run 2 minutes ago, and it has a name of evil Rotten Gen. That's a randomly assigned name, and they get a little confusing if you randomly assign them, so we'll show specifying a name later. But let's go ahead, and if I were to restart that image, let me mark it and get the image ID. Usually you can reference by image ID pretty easily. So docker run, and to give it the image ID, paste. Oh, sorry, docker start. Docker run tried to build another container. Actually didn't mean to do that. Docker start. And it goes ahead and builds it again. It's echoing internally since I don't have an attachment, but it starts it up and shuts it down. By default, Docker will start a container, execute the command you've given it, and then shut down as soon as it no longer is needed. You can start it as a daemon, so the -d flag that we'll use later, that's very common. But if you only want to run, let's say, a Python script or something like that, you can easily do docker run, give it a single Python directory to go against, let it run it, and get the output from it, and the Docker container will shut down. So docker PSA again, and we see that that container is still there. So let's go ahead and delete that. Docker remove, and just give it the container name, and that will delete the container. I try to be aggressive about deleting my containers because when I don't need them, because you can get a lot of them very quickly, especially if you're launching and shutting down and relaunching containers, and that gets to be confusing over time, and just they can collide, names can collide, and it won't run. So it's a really good habit to get into, aggressively cleaning out your containers. All right, so let's start a bash shell with Docker, and we'll have to run it sort of interactively. So docker run, I is the interactive flag, T is as a sudo ttdy cursor. So let me give name. I'm going to name it this time, and I'm going to call this container app1. And it's important to realize the difference between a named container and a named image. Those are not the same thing, so keep track of them in your mind. So from this, I named the container app1. I'm going to use the image Ubuntu. And this time I want to specify a specific tag version. So I'm going to do 1404 as a specific tag version. And I'm going to give it the command bin bash. And when I run it, it hasn't pulled down Ubuntu 14.4, so it's going to pull down those layers from Docker Hub again and build them. And each one of those is a commit layer from a previous version that it can build up over time. I suggest you do some Googling on the union, what they call the union file system used in Docker. It's very fascinating, and it allows you to kind of version these images over time, but I'm not going to get into it here. So I've been dumped out to root. I'm in Docker as a root user. It dumps me right out to root. My present working directory is at root. If I list, you can see the file system for Docker right here. So this is my bash session running. So I'm going to go down and go ahead and add a directory here to show that I can modify a container. So make dir, let's call it opt, and oops, I meant make dir opt app1. So if I list opt, I have an app1 directory that's been created, and that now has modified this container. Now that does not modify the underlying image. So, and that's an important thing to understand about this. So if I were to exit this, docker PSA, so I still have the container. It's exited, its status is exited, but it's still a container. I can still rerun it and get back to the bash session if I want. And its name is app1. So let me restart another container using that same image. Docker run -it. You can combine the flags obviously like you can in most Linux command. Name, not app1. I'll use the Ubuntu 14.4 image. That's the image name, and you put a colon in there in the tag, so 1404. And I'm going to bin bash. And now what you'll see, this is going to happen quickly, so I'll say it before I hit return. Since images are only pulled down once the image is on your local system, Docker can use that image and spawn a container very quickly. So whereas you before up here, you saw all this kind of pulling complete, and it does the checksumming of the different layers. When I hit return this time, it's going to come right back and launch it immediately. So it's extremely quickly. Extremely quick. That's a great feature of Docker for people. So if I ls again, I'm root at the root directory. If I ls the opt folder, you'll see there's nothing in it. So now the changes I made that you saw earlier were only made in that container, and those changes aren't in this container. They're entirely separate. So although I've launched them from the same image, I get a pristine version of that image every time I launch a new container with it. So if I exit, I'll get that. So let me go ahead and reattach a bash session so I can show you. If I docker PSA, you can see I have the app1 and the not app1 containers. They both came from the Ubuntu 14.4 image. They have some commands. All right, I got myself tripped up there. So hopefully I'll edit this out. All right, so actually what I needed to do was go ahead to start that container with Docker. Go ahead and all right, so let's go ahead and start app1 again and show you what's inside that container. You see some scroll here. I had a little senior moment there and I couldn't remember the command properly, so I cut that out of this video. But let's go back and Docker start interactive, and if I gave it name app1, I immediately get the root credential again. I didn't have to pass in the command because the command is saved. When you stop and start a container, it is stopped and started. It started at least with the same command that you give it when you created it. So that's important to know. So I get back to my bash shell. Now if I go to my bash shell and opt, list opt, I should see my app1 directory. So that exists in the app1 container, but not in the not app1 container. So it's important to realize that these containers are separate and they're not, they don't interact with each other unless you give them some commands to after that. So I've exited Docker PSA, and you can see there's nothing running as a daemon, so that is exited as well. So I'm going to go ahead and clean both of these up. There's a little command that is useful to get to know, because there's no bulk clean command for Docker containers, at least right now. We hope in a future version of Docker we'll find that. But if you want to remove all containers, you can docker remove, pass it a verbose for the ID numbers, and then get this command docker ps -q, which returns only the container IDs from them. So that's an easy way to sort of iterate through and delete all of the Docker containers, and that just iterates through all of those. So if I docker PSA now, I get nothing, and so I've got no container sitting on my system. All right, so that's a simple how you run a Docker command and get things in. I'm not going to cover commits in this video. We'll do that at a different date, because really you don't commit directly. You do something called the dockerfile. So I'll cover that in a dockerfile episode. But know that, let's say I wanted to take that Docker1 app and create an image from it. I could use a command called docker commit to save that to an image, give it a tag locally, and then push it to Docker Hub. But that's not general, although you can do that, that's generally not the paradigm people use. They usually use something called the Dockerfile. And actually, well, I'm going to do a lot of command line stuff, but often that's declared out of Docker files for convenience. So people don't often brute force it from the command line. They do most of the build instructions to a Dockerfile and then declare what they need to about specifics about ports and such at the runtime. However, but for learning, we'll do a lot of it by command line here, and you'll see a little bit of Dockerfile by the end of this. All right. So I'm not going to get into, you just know you can commit that image if you want to create a new image. If you give it the same name with a different tag, it creates a new version of that image. You can push it to Docker Hub if you want. But those are some of the things that are available to you as options when you're operating with this. All right. Let's look again, images, Docker images. I know I've got Ubuntu latest, I've got Ubuntu 14.4, and I've got an nginx latest on here. So let's get through and show what it takes to run a small static website. So I have this nginx image on here, so you won't see a lot of this build again. But I just want to show you how to put how to get up a website, a simple website, and run it. Let's say you have a website you're debugging on your local system. This will only work with static websites, obviously, but I often use this if I just want to edit a website and see what it looks like in a real web engine. So I can run an nginx engine, a website anyway. Let me go ahead and paste in this command. So it's docker run. I'm naming this nginx standard. I'm giving it a volume of user share nginx HTML. Anyone who's used nginx knows that's the web root for nginx. I'm running it as a daemon, and I'm using the image nginx, which I have it built on my system, but because it doesn't have a username, we know that that's an official build from the nginx folks. There's a couple things going on here I want to talk about their addition to what we've seen before. First is the idea of a volume. The Union file system lets you build up layers of disk images over time, and that's great for building disk images, committing them to GitHub and getting them. But a lot of apps, you don't want to version those files, so you can create what's called a data volume. That's a separate read-write layer in the container. It is excluded from the image process, so it won't be committed on an image commit. You can do a few things like mount that to the local file system, but it's often used for parts of an application whose files change frequently that you don't want to push up into a commit. So if you have a Postgres Docker container running, usually the database for that, you don't want to commit that as part of an image. You just want the binaries for Postgres, for instance. So you'll put an image around that. In this case, we have a website. We want to make sure this image contains the binaries for nginx to run the nginx application. But we don't necessarily want to commit the web files to a disk image, and we'll declare that to a volume. You can do things like mount a volume inside a container to a local directory. That's often useful, and people do that frequently in develop. You never want to do that, however, in a production container, or actually a container being served to the outside world at all. And that is because containers are sandbox, and we'll get to that a little bit in a multi-container episode in the future. But the containers are sandbox. They're able to, by default, talk to one another, within their internal Docker networking. But unless you expose a port to the outside world, nothing can get to those Docker containers except the Docker engine itself. It's a security feature of Docker, and it's a good way to sandbox content and provide security for your containers in across a bunch of containers that might be running. And one of the concepts of Docker is to atomize Docker containers as much as possible. So you want to limit containers to a single service or application running. And if you need a full application that has multiple services, you want to connect individual containers that are running. And we'll do that in a future episode together. So you really want to limit the exposure of different components of your application to each other, and only do what you explicitly declare. And that's a central concept. So be aware, if you're mounting a local file system, you only want to do that on a local development machine. The other thing to quickly cover is I'm actually running this as Docker Toolbox in Windows. I expect this problem to go away, but there's a known bug with VirtualBox, which is what Docker Toolbox runs on Windows, that it messes with the inodes on a Linux machine. I'm not going to get into inodes, but it detaches the inodes once it's running in a container so that the file reference doesn't hold for local mounts, and there's some problems with getting new files over to your Docker image. So that's why I'm not using a locally mounted volume. But all right, back to this. I'm going to take Docker, run a container. I'm going to name it nginx standard, std, for lack of a better term. I'm going to give it a volume of that HTML directory. I'm going to run it demonized, and I'm going to run nginx itself. And that's the application to run. So hitting return. Since I have that image on my machine, it comes very, very quickly. One of the other artifacts of running on Docker Toolbox is you can't, whereas if this was a Linux machine, you could directly use localhost or 127.0.0.1 as the IP to get to that website. However, since this is Docker Toolbox, in fact, what's happening is it's running on a local VM on VirtualBox and actually using the image there. So you have to put in whatever IP VirtualBox is assigned to that version that it's running Docker on top of, which in most cases it's 192, 168.99, 100. So don't worry about the port number. So I'll show you here. I have that. If I hit reload, however, this is going to return nothing for me. And that's because although the application is running and Docker has done something called expose a port, I've not actually mapped that port to anything. So by default, Docker does not it might expose a port and make that available when you run it, but unless you specify that port to be mapped when you run it, it won't map it to anything. So a quick way to find that out is if we go back here, Docker PSA, we see that these ports are exposed, but they're not actually mapped to any local directory. So that's useless to us. So let's go ahead and turn it off. And by the way, this nginx command, this comes from the definition of the official image we pulled down. When it runs nginx, it's actually running nginx with this command, daemon off and G. So an application in a Docker container has to run in the foreground, or Docker doesn't know something's running and it'll shut the container down. So in nginx parlance, that's how you run it in the foreground. You don't want to run applications in the background. So let me shut down this container. Docker stop nginx std, because that's what I called it. And I'm going to remove it. Docker remove nginx standard. All right. So it's removed. If I docker PSA, you see it's not there. So let me go ahead and start it. This time I'm going to start it with a command that maps the ports to a local port that I might want to use. Now I'm going to do this. Let's do it this way first of all. If you do the capital P for port, what that will do is randomly assign a local port number to the exposed ports that are provided with a disk image. Again, those exposed ports were defined by the nginx folks when they built that image. So I'll do the capital P, I'll hit return, and this time if I docker PSA, what that's going to bring back is it shows me here that these port 80 and port 443, so the standard HTTP and HTTPS ports were not mapped to anything before. Now they're randomly mapped to 32.769. So if I go back to this and put in 32.769, welcome to nginx. So I get the actual service now. I can get to it since I mapped that port. That's an important security feature of this. So let's go ahead and do something a little bit more complex and shut this down. And we will docker stop nginx standard nginx. Do that all on one line. So docker ps. Hey, see nothing there. Okay, so let's go ahead and actually map that to a port in some way that we can use it, and we need to get files in there as well. So we'll do that in a second. So let's use a modified version of the command we just did. If you give it a lowercase p, you can specify port numbers that you want it mapped to. So in my case, I'm just going to use port 80 so I don't get into any confusion. I can use 8080 or 8081, but that lets me say the local port that I want to map it to and the exposed port on the container that I want to map it to. That's what that is. So if I hit return, it'll run the container. Again, it runs very quickly. If I go back to the website, if I hit this with this port number again, it should give me back nothing, exactly as expected. If I take that out and go off a normal port 80, it will give me the hello world again. Now that's not very interesting. So let's actually inject a website into there. Once I have a container running, I can go ahead, docker ps, I have that container running. I can go ahead and actually copy files into it. And I'm going to go down into HTML. I have in this directory a pre-generated website using HTML5 boilerplate stuff that I'm going to go ahead and use it. For this example, I'm going to use the docker copy command. So I've got a Docker container running. I want to take files from the local file system and inject them essentially into the container. The way I'm going to do that is I'm going to use the docker cp command for copy. And what this tells it is I docker copy. I'm going to do this for the current directory. I'm giving it the container name, which is nginx std, as I said before, standard. And this is the directory inside the container to go to. I could reverse that and copy files out of the container, but here I'm copying files into it. And again, that's a volume, so those shouldn't change the image if we ever save that image. All right, so having done that, if I go back to here, I get now the website that I just put in there. So it's a very simple hello world thing, and it injects files into that. You can do that repeatedly over time. Actually, that's not the normal workflow that people do, and I'll show you something called Docker, how they do it in a Docker file here shortly. Or often in development, people will mount that to a local drive, but again, there's some problems around that with Windows file systems and VirtualBox. So, but that's an easy way to get files in there. So it's a very low bar way to do it. All right. So I've talked a little bit about dockerfile and how that goes. So let me docker and PSA docker remove nginx. Oops, I gotta stop it first. Docker stop and docker remove engine. All right, so I've got it removed. Now I've got no Docker containers on my system, but again, I have a bunch of Docker images that I've been working with over time. So instead, let me go ahead and show you what I would do if I was going to use something called the Dockerfile. And I'll do a whole different episode about Dockerfile itself, but this is the directory I just was in. What Dockerfile does is it specifies a build for an image on your system. So you can either build it and then have it on your local system and then spawn services from there. It's an easy way. You don't necessarily have to commit new changes for Docker, for a Docker file to Docker Hub itself. You might just have an image which has you 99% of the way there, and you know that if you just build the Docker file with a few extra instructions that will give you the local image that you want, you can spawn containers from there. At the point, you have to make a decision as a developer, what point is the right point for you to build your own Docker image, or just build an image locally from a Docker file, a Docker image you're pulling down from Docker Hub using a Docker file on your local system. That's something you'll have to decide. And we'll get more into this in sort of the Docker file episode, but I just want to cover that it exists at all. So here what I'm doing is I'm going to build an image from this. And again, it's important to understand you build images and you run containers from images. So in this, what I'm specifying, instead of the nginx standard image, I'm using the Ubuntu 1404 image as my base image for this. I provide some information like who's maintaining it. I give it some commands to run in the image as it's building it. So as the image is being built, it's going to pull down Ubuntu 14.4. Then it's going to run apt-get update and apt-get install nginx. I'm going to declare a volume here of user share nginx HTML. I'm going to expose the port of 80 so that, again, that doesn't actually make it available. That only makes it available in Docker run if you map a port to it. And if you try to map a port that isn't exposed, it won't work. Next thing I'm going to do is I'm going to take all the files in the local directory. I'm going to copy them into this image. So you may not want to actually do that in the real world, but this image is going to be built with all that static web content bundled into it to begin with. So when I launch it, I don't have to do a lot of these commands. I'm going to change the working directory to this to that HTML directory. I probably don't need it, but you can specify a working directory if you want. And I'm going to give it an endpoint, which means this is when any command is run, it's always run against that endpoint. So in my case, the endpoint is always going to be user sbin nginx, which is the only thing I want running in that container. And I'm going to specify daemon off, so it's run as a foreground operation. All right, so that's how you build the image. So let's build the image and get it ready to run as a container of our own. So that's with the docker build command. So you can preload an image from Docker Hub or a private repository with something called docker pull. So it's just pull down like a git clone. But if you want to build an image from a Docker file, what you're going to do is specify docker build. Give it a tag name, so that's what you want to name the image in a local on your local file system. You can use that to push to your repository at a later date. So it's very useful. When you build an image, it's good practice to, even if you're only going to store it locally, name it with the user or the company, and I will call this one my website, and you do a colon and give it a tag of your own. Tags again are free text. You can put in whatever you want. Normal practice is to usually do it like you would with tag releases on something like GitHub. So in my case, I'm going at 0.1. And then you want to specify what Docker file you want it to build using. Now, since I'm in the directory where the Docker file exists, I'm going to give it a dot. So current directory, although there's a way to specify a Docker file in another directory if you want. So this is, so I'm building an image. I'm tagging it with Streamweaver, my website, 0.1, and I'm using a local Docker file to do it. So when I hit return, it's going to go ahead. It gives me some of the commands that are in there. It's going to start pulling down the images. Since I already have Ubuntu 14.4 on my local system, it doesn't need to go out to Docker Hub for that. So it starts right away using the 14.4 image. It starts running the apt-get update, which you're seeing run right now. And then it's going to go ahead and install nginx as well. And it's a great way to get a pre-built image on your system if you need to run something locally. Additionally, it's going to take all the local file content and copy it into that image. So the last bit we're going to do when this builds is we're going to go over and we're going to we're going to launch that as a container, and we're going to show that it runs. Because again, this is just something that runs that builds an image on your local system. It does not produce a container until you use the docker run command from that new image name. This is going to scroll through a bunch of content, and once we're at it, it gives me a security warning at the end. By the way, it's just because I'm running on Windows. You can ignore it for Windows machine, but for playing around, Windows it's just fine, but I don't recommend it, at least right now for production. That's supposed to change, as I said before, very soon. Will you be able to do it from PowerShell just fine? All right, so if I docker image, it will show that I have Streamweaver, my website, with a tag of 0.1. There's no latest build locally, so I have to always specify that tag. So if I'm actually going to run a container, so if I docker, you can see there's no containers running. So if I docker run, I want to daemonize it. I want to give it a port of 80, local port 80 to container port 80 in this case. And I want to name it nginx local, and I'll give it and then I need to give it the image that I'm pulling from. So Streamweaver, my website, and the tag. Since I don't have a latest, I have to specify a tag. And notice in this case, I don't have to give it actual commands because I defined the command in the endpoint entry point directive inside the Docker file. So I don't need to give it commands here that will run with those commands by default. So if I do it, again, it starts very, very quickly. If I go over, I hit refresh, it will load so that web page is running. If I go into Docker PSA, you can see that it's running as an image, and it will keep running until I shut it down. So if I docker stop nginx local, now we'll shut that down. So if I reload it, it will just give me no response. And that's an easy way to swap out website content, is to switch out containers on the back end with map ports and so forth. So it's a useful technique. All right, so that's the very basics and introduction to Docker run, Docker build, listing Docker images, and cleaning your system up, and to do a few things like that. So that's how Docker images are basically run. I think next episode I'm either going to do volumes or Docker files. I'm deciding right now which one it will be, but I hope you enjoyed this. We'll continue on with the series over time. So thank you for joining me, and go out and play around with Docker. I hope you have some fun. Thank you.